Okay, can every one of you hear me? Write a yes or no in the chat. Alright, can everyone hear me? Write a yes or no in the chat. Alright, thank you. So, hello everyone, welcome to this webinar on natural language processing. I would like to welcome my friend Pritam Deka. He's right there. Hello, Pritam. Uh, so, Pritam, your microphone is off, by the way. So, be aware of that. Anyway, Pritam Deka, he and I studied together in Tezpur University for our masters, and then he taught in Royal Global University as a lecturer in computer science for around a year, right? And after that, he went for his PhD at Queen's University, Belfast, which is in Northern Ireland, UK. Right now he is doing his PhD. He has been doing his PhD from his residence in UK from his home because of this coronavirus. And in this webinar today and tomorrow, he is going to talk a little bit about what is NLP and his perspective on this topic, and he is going to uh, give a presentation, right? So, having said that, I would like to welcome Pritam to this webinar. Thank you for being here. And apart from thanking Pritam, I would like to thank Akanksha, Meghna, Anushika, Rispan, Swapnil, and Subharan. So, you guys, thank you for organizing this webinar, and I hope we will be able to organize such webinar in the future as well. All right. How many of you are from 7SEM CSE? Can someone just give me write something in the chat? I know Anisha is here. All right. So Vedashri is here. All right. Bobby, Munira. Okay. A few of you are from 7SEM. Rest of you are from. How many of you are not from CSE? Means from some other batch. Tapash is there, right? Okay. So, Pritam, do consider this fact that there are people from outside CSE, computer science. So, do consider that. Okay. Having said that,
Yeah, sure.
okay, Tapash is from CSE. Okay, fine. Anyway, there are a few people who are from not from CSE. Dipam, you can
Mhm.
turn off your camera if you want. All right. So, yeah, I'm handing over to you, Pritam. You can start.
Okay, thank you.
All right.
So I hope everyone can hear me.
Yes, sir.
Yes, sir.
Yeah, yeah, sure.
Yes.
Thanks. Yeah, thank you. So yeah, I'm sharing the screen now. Also, I sent a notebook. Have you guys got the notebook I sent to Akanksha?
Sir, I've mailed them to everyone. I think if they
Okay,
check their
yeah,
emails, they'll get.
yeah, yeah, sure. Okay, guys, check your email. There should be a notebook. Download that notebook. I'll tell you how to use the notebook because we'll have some hands-on practical stuff also today. It'll be basic things. So yeah, if you can download the notebook, I'll tell you how to open it. Okay, I'll just start with the slides. Okay, can you see the slides?
Yes,
Yes,
sir.
sir.
Okay, but I can see the slides, right? Wait. Okay. Yeah, is it visible?
Yeah, yes, sir.
Mm. Okay, so yeah. So I'll just start with the basics of NLP. Like, what exactly is NLP? So I think you guys are familiar with artificial intelligence a bit. So basically, NLP is a subfield of artificial intelligence which deals with stuff that we humans have to, I mean, how to interact with the machines in our natural language. Like, uh, yeah, I can. Okay, there's a lot of noise. Uh, yeah, thank you. So, uh, yeah, how to deal with machines in our natural language is what NLP is all about. So, it may be in the form of text, it may be in the form of speech. So, it's a subfield of artificial intelligence. So, like the first point, it helps computers understand, interpret, and manipulate human language. So, human language may be English or it may be any other language that we use for our day-to-day conversations and stuff. Then, so basically, NLP, it is, I mean, it is not a particular field of only computer science. It is related to many other fields also because this is an interdisciplinary field. Uh, NLP is based on languages, so we need linguists also. So it is like it is across many disciplines, which includes computer science and computational linguistics and other few other stuff as well. Because for speech we need electricals and electronics and stuff like that. So physics is also there. So it is a multidisciplinary field. It Yeah, so the third point is the same as the first point. So it makes possible, it makes it makes it, I mean, NLP makes it possible for computers to understand and read text, hear speech, interpret the meanings, measure sentiments, and determine which parts are important. So we can basically take any text and work on it so that we can extract some kind of information from text as well as speech, which makes sense to the computers. So usage of NLP. So it's used across many fields like content categorization. So it's like document summarization. So suppose we have some few documents and we want to summarize it. So NLP, it can be used. I mean, I'll basically talk about text related things. I'll not go for the speech because my research domain is basically only on text processing. So I'll just talk about text processing. Then we have topic discovery and modeling. So topic discovery and modeling is like suppose particular document is based on cricket. So the topic is cricket, but suppose we haven't mentioned it that this document is based on cricket, then we can use topic modeling, which a kind of NLP task that we can use. So we can use topic modeling to discover the topic which is being used in the whole document. So topic discovery and modeling. Then contextual extraction. So it's like pulling out structured information from text sources. Structured information means like, for an example, we can take the health sector. So uh, in hospitals, doctors, they write stuff like patient's information, what kind of dosage he was given. So all these are structured information, but to extract the information like patient's name or what kind of medicine he was given, all these things, those are called contextual extraction. Then we have something called sentiment analysis, which is like identifying the mood and opinions and within large amounts of text. It's basically like reviews kind of thing, movie reviews or hotel reviews, restaurant reviews. Those falls under sentiment analysis. This is just a pictorial description of what I just said, like information retrieval, sentiment analysis, information extraction. So there's question answering. So yeah, question answering is interesting because suppose we ask the machine some kind of question, then it will give answers. This is being used by many companies or something. We may see some sort in a few websites or few companies. You will see some kind of uh, chatbot option kind of thing. So you can ask anything and it will reply back. So that's a part of question answering thing. Then we have something known as machine translation. So machine translation is translating a language to another language, which Google Translate uses. So if you type in English, then you can get the equivalent thing in any other language. So that's machine translation. Then we also have speech to text and text to speech conversion. So speech to text, very good examples are Apple Siri, Google Assistant, Alexa, and things like that. So those are speech to text applications. Then document summarization, summarizing a whole document. Suppose we have a very large document and we just want a particular summarization of it. To understand it better, then we can use this document summarization. So that's also a task in NLP. So NLP, I mean text processing. And machine translation, I have already said machine translation. So yeah, now before before we can process any text, we have to pre-process the text. Pre-processing means removing unwanted stuff, unwanted noises, things like that. So that's pre-processing. Now, why do we need to prepare text data? Because we cannot simply use text for analyzing anything, right? Because computers don't understand, like, I mean, text. They just understand zeros and ones. So we have to convert in some way the text into numerical data before we can work on it. So that's that. I mean, conversion from text to numbers is known as encoding. So that's the process. So, but I'll go into details about encoding later. But before we can encode text, we just have to first see the whole text if it contains some kind of noises, because any text that we can download from the internet, it contains lots of noises like URLs, unwanted characters. Suppose there are lots of hashtags, dates, and stuff like that. We don't need all these things. So we have to remove all this stuff before we can convert text to numbers. So yeah, so I'll just go and show you some ways of pre-processing text. Pre-processing, it means the cleaning of the text before we can use. So this is a simple pipeline. So we have a raw text. We just remove those URLs, HTML tags, and there's something called stop words, punctuations, white spaces, etc. After all these removals, what we will do is we will do the text normalization, which includes tokenization, limitization, stemming, sentence segmentation, etc. Then word standardization, regular expression. We can use these things. We may not use these things. These are just optional. And then we get the cleaned text. Okay, so I'll just show you a few. Yeah. So is the slides visible?
Yes, sir.
Yes, sir.
Yeah, yeah, yeah. Thank you, thank you. So these are the steps. Like first is the removal of URLs. So then we have removal of irrelevant characters, numbers, and punctuations. Like in some cases, we need not remove numbers because those may be of importance, especially in biomedical text. There are many numbers in biomedical text which we need, so we don't need to remove the numbers in those kind of text, but in other text we may remove. So it depends on the kind of processing that you want to do, on which kind of text you want to process. Sorry. Yeah. Can you hear me?
Yes, sir.
am I audible?
Yes, sir.
Yeah, thank you. Wait, kind of. Okay, yeah. Sorry. Okay, so that's the removing of irrelevant characters and stuff like that. After that, conversion of all characters into lowercase. Lowercase, converting the capitals to lower cases. That's the thing. Then we have something known as tokenization. So tokenization, it falls under text normalization. So tokenization means splitting the whole given text into smaller pieces, which are called tokens. Uh, we can take anything like words, numbers, punctuation marks, and things as tokens. But before tokenizing, we remove those punctuation marks and stuff like that. So, so that's word tokenization. I mean, splitting the text into small pieces. Though that's word tokenization. We may sometimes need the whole paragraph into sentences. So then it's known as sentence tokenization. I'll show you how to do this. I think you all have the notebook with you. So I'll just show you how to do. And then we have something known as stopwords removal. So stopwords are the common words in any language, like all these words. So there's a list of stopwords. You can remove those stopwords if you want. If you don't want to remove, then also it's fine. For some cases, it's important. For some cases, it's not. I mean, it's not advisable to remove stopwords beforehand. So that's the removal of stopwords. So yeah, this is just a picture of sentence tokenization. Uh, okay, I'll just show the notebook here. Okay, can you guys just open Google Colab on your laptops if you can? Then you can just try on the codes. Can you guys open the notebook?
Yes.
Okay, thank you. So yeah, you can just try out the first cell. So I just explained like what's the first cell. So if you guys don't know Colab, then I'll just show you like what exactly is Colab. So Google has this new thing called Google Collab. So using Colab, you can run Jupyter notebooks, and you can also do Python stuff also. So it's very useful for us, like if you want to just work on work on a cloud computing kind of thing. So uh, this is just a simple notebook that I have prepared for you. Now, the first cell is it's importing NLTK. So NLTK is a library which has many of the modules such as stopwords and all this stuff. So for our purpose, we'll just run this first cell so that we can later on use the whole thing instead of running everything. Yeah, so this is done. Now we'll just see an example of sentence tokenization. So I have just taken a simple paragraph from Wikipedia. It's just a cricket kind of thing. So this is the whole text. Uh, so we'll import NLTK again. NLTK is the library. So from NLTK, we'll import this module. So modules are a kind of functions that we can use. Then we have this text. So this is the whole text, and we want to divide this text into sentences, right? So what we'll do is we'll take these sentences variable, and these sentences will be assigned this. So this means this is a inbuilt function or module you can say, because in Python we say module. So this is the inbuilt module which divides the whole text into sentences. So it's very easy to actually use all these things in Python. Then this is a for loop in Python. So for each sentence in sentences, we will print the sentence. So we will get sentences from this text from this. Then for each of the sentence, we will just display the sentence. So this is what this particular for loop means. So it's very similar to what for loop that we use in C or C++ programming. Just the syntax is a little bit different. So we will just run this cell. So as you can see, this is one sentence. This is another sentence. So sentences are actually divided on the basis of full stops. This is another sentence. This is another, and this is another. This is the last sentence. So we have divided this whole paragraph into sentences. Now we can work on sentences individually. So this becomes important if you are working with something like text summarization and stuff like that. We will see this later on. So I have some text summarization kind of notebook also for you guys. So this is just sentence tokenization. We have divided the whole sentence into divided the whole paragraph into sentences. So this paragraph can be a huge document also, or it can be a collection of documents. Like this is just a simple text, like one paragraph. Now you can work on huge data of text also. Like it can be something like many files. So those files may contain many sentences, and we can divide everything into sentences. So this is the basic thing. Then we have word tokenization. So I'll just take a sentence. Okay, this is a simple sentence. This is an example of how to tokenize a sentence into words. So we'll just divide into tokens. Just run the cell. So these are individual tokens. This is an example. Okay, so even this is a token. The full stop is also a token. So this is a simple tokenization. Now tokenization is important when you have to do a certain task such as named entity recognition, or parts of speech tagging, or noun phrases. Uh, you have to divide sentences into noun phrases. Then this tokenization is very important. So you don't need to know now, like why to use or when to use. Just know that this is how we tokenize a sentence. So we have a sentence, then this is similar. Just for word, we just use word. Like for sentence, we used sent. And for word, we just use word. So these are already built-in modules in the NLTK library. You just have to use this, and just for the variable, you have to just pass on the sentence. Okay. whatever sentence is used. Then you will, I mean, you will get the tokenized version of the whole sentence. So it's very, very easy. Then, yeah, so this, let this be fine now. Okay, I'll just then go back to the slide. Okay, so I think that's clear for you guys. Next, we'll move on to stemming and lemmatization. So, what's exactly stemming? Like, stemming is the process of reducing inflection towards the root word forms. Like, for an example, we have something known as play. This is the word, and it's the base word. And playing, played, plays are the different forms of the word. So, this is the root word. Now, what stemming does is it'll convert all this to the root word play. So that's stemming. Stemming is important in many tasks. Another method is lemmatization. It also switches any word to the base word, but there's a little bit of difference. So in lemmatization, what happens is if we have some kind of word like troubled, then the root word will be trouble. Okay. So for stemming, what it'll do is for troubled, the root word will be trouble. But what stemming will do is it'll remove only the ed part. So we'll get something known as this word, which is actually nothing, right? So this word doesn't mean anything. So it'll be an error in certain cases. So we have to be uh, clear, like if we want lemmatization or stemming to do. So there's this example. So you can see this is the original word connect and the stemmed words. So it just removes the ed, then ion. Okay, all these things it will remove. But if the word is something like trouble and the word is trouble, then removing ed will just lead to this kind of words which do not make any sense. So lemmatization, however, it just converts to the base word. So it can be anything. It will convert to the base word. So yeah. So I have an example that I can show you. Okay. Okay. I'll just show everything, even stopwatch removal and characters removal from the. Uh, okay. Yeah. So yeah, lemmatization and stemming. So we can see the difference. So this is another. This is the same NLTK library. So we'll just import all these modules from this NLTK library. So NLTK library is actually a very large library for natural language processing. It's basically used by everyone. There are a few other libraries also which are similar to NLTK, such as Spacey. Spacey is a new library, so we can use Spacey. We can use NLTK for our purposes. Uh, Spacey is actually very fast and it is very I mean very fast, faster than NLTK. But yeah, you can use anything like NLTK or Spacey. If you want, you can just take notes of these things. You can look up Spacey and stuff like this later on. So yeah, from NLTK we will just import all these built-in modules. So these are already there. You just have to use it, and we will just. This is just a function. Okay, this is how you create a function in Python. We use the word def and then give the function name and the variables inside it. So this is how we create a function in Python. So we'll just create a function and we will define the function here. So this is just a commented out part. Okay, this will not come in the uh, it will not come in the results. Okay, this is the commented out part. You can use this, or you can use the hash for commenting things. Like if I remove this, then you can use the hash, so it will turn into green. So this is just the commented out part. Okay, sorry, this is lemmatization. Okay, now this is print function. So print is just displaying the output. So we use print for C and C++. It's different. I think for C++ it's C out. Uh, yeah. So for Python it's print. So print, then anything it will display. So this print, then this stemmer. So this will display as like this, and this rest is the variable. Okay. So this is just the word, and this is the variable kind of thing. Then lematizer is this one. This is this is the definition of the whole function. So we have something. We'll pass on these words stemmer, lematizer, and this the word that we want to lematize or stem, and then the POS. So POS means parts of speech. So okay, now lematizer it calls WordNet lematizer. Okay, WordNet lematizer is the built-in module of NLTK. So it will just perform its work. You just have to call this, and it will do the whole thing itself. Even porter stemmer. So we have many modules for stemming and lemmatization. I have used porter stemmer and WordNet lematizer. You can use any other stemmer or lematizer. So there are many. You can just look it up. Then we will just call the function. We will pass the stemmer and lematizer from here, and the word. Okay, I have used troubled and drove. Now POS is verb. So these two words are verbs. So we have, that's why given this as wordnet dot verb. So for parts of speech, you can just check up all the words. You just enter a word, use wordnet to get if it's a verb or it's something else. So for our purpose, we are using verb. So that's the POS. Then if we run the cell, you can see we get stammer trouble. You can write any other word, suppose playing. You can just try out. So yeah, so for playing, it'll just go with the root word, which is play. For drove, it's the since we don't have anything, so the stemmer will not be able to stem the word. But for lematizer, it will go for the root word, which is drive. So you can use any other word. Uh, just give me some word which ends with okay, maybe anything like running. Yeah, so you can see for running, it'll first stemmer will remove this part and give the run, and lematizer will return to the original the root word. Okay, so this is the basic difference between lemmatization and stemming. Okay, then we have something known as stopwatch removal. So I have already said so as you can see, I have imported stopwords and I have set the stopwords to English. Okay, so this whole thing will just remove all the stop words which is present in the English language. So they already have a list of stop words. Then we'll take this sentence, like this is a simple sentence. So the stop words will be removed from this sentence. So the stop words is of the, and these are not stop words. So since these kind of words appear very frequently, so these are removed from the sentence if we use stop words removal thing. So what we do is, uh, okay. So the words are first tokenized. Okay, this is the word tokenization that I have already explained before. And so we'll get the list of words, okay, from this tokenization, word tokenization. After that, what we will do is we will check if the words in present in here are present in the list of stop words. So this is what this means. Okay, word for word in words. Okay, this whole thing, it means that for each word which is present in this list of words, if it is not in stop words, okay, if not word in stop words. So this is how you write. So this is actually a very short form of writing a for loop. Okay, so this is known as, I'll just write the name. So this is actually known as list comprehension. Okay, list comprehension in Python. You can just look it up. If you aren't familiar with Python, then I suggest you just go through the basics of Python. It's very easy. You can take any tutorial and learn Python. So in Python, basically, for NLP purposes, basically we use two very powerful data structures. So one is list, sorry, and the other is dictionary. So these two are used very frequently, and list comprehension is very powerful, as well as dictionary comprehension. So you can do a lot of things with list and dictionaries. So this particular thing is known as a list comprehension. It is shortened in just one line. So this particular will have the list of all the words except the stop words. So as you can see, this is what it returned. So yeah, this is stopwatch removal. Then we have something known as removing characters which are not words. Suppose we have these kind of characters, hashtag, at the rate, percentage, okay, and commas and this everything. Okay, so we want to remove all these things, commas, punctuations, and at the rates and anything. So what we will do is we will import this library. RE. RE is regular expressions. Okay, so regular expressions library. I think if you have studied theory of computation or flat formal languages automata theory, you will know what regular expressions are. So we use regular expressions a lot in NLP. So this whole library, it contains all the modules which are related to regular expressions. Now, this is the whole sentence, okay? And the pattern we need is, okay, so this is a not, and this is W is like words, okay? Not words are removed, okay? It's not exactly removed, like we take the pattern, which are not words, and then we replace them with a blank space. This is a blank space. And then we just display the whole sentence. So if we run this, we can see that this hashtag is removed and replaced with a blank space. These two are removed, replaced with a blank space. Commas are removed and replaced with blank spaces. So not word are replaced with blank spaces. So uh, yeah, this takes care of everything. So this is very powerful. Regular expressions. So we have a list of other regular expressions which you can use to remove anything from any sentence. You can remove numbers also, or you can just remove the hashtags and include numbers. So it depends on you. We can use any regular regular expression. Okay, so I think this much is clear for you guys. If you have any doubts, you can ask if you want. Okay, shall I continue?
So,
Yeah,
hello, sir.
yeah, yeah.
I just wanted to ask if lemmatization is more efficient than stemming, then why do we use stemming?
Yeah, so yeah, that's a good question. So it depends on the particular task that you are doing. So sometimes lemmatization is very important, but sometimes stemming is very important. Like you can see the word drove was replaced with drive in lemmatization, right? But you don't need sometimes that kind of thing. You need the whole word drove only. In those cases, we use stemming. That's more important. I mean, that's the thing that you have to remember. You don't want the whole word to be changed into some other word. In those cases, you need stemming. In the other cases, you can use lemmatization. Okay.
Okay, sir. Thank you.
Yeah. Thank you. So yeah, before going to this bag of words thing, I'll have to explain what exactly is bag of words. So I'll go back to the slides. Okay. Yeah. So we'll come to something known as feature engineering. So feature engineering is done after the pre-processing of text has been done. Now, after pre-processing text, we will get the clean version of text. Now we want to uh, work on this clean version of text, that is extracting information from the whole text. So feature engineering, it consists of tasks like POS tags. So POS means parts of speech tags. So parts of speech is what you have learned in English language, but you don't need to go into details because NLTK takes care of everything. So yeah, every word in a sentence is associated with a part of speech, like nouns, verbs, adjectives, adverbs. Okay, so if you want parts of speech tags, then you can extract that information using the inbuilt modules. This is important when you are working with something like extracting some kind of information. Then you need parts of speech tags. Then we have named entity recognition. So these things are like detecting named entities such as person names, location names, company names from a text. I'll just show you how this works. Okay. So this first diagram is parts of speech tagging. So I want an early update. So I is a pronoun. This is a verb. This is a determinant, adjective, and noun. So you can collect information of every sentence using NLTK library. So we already have parts of speech things inbuilt. You can input any sentence and you can get all the parts of speech for all the words. Then this particular diagram is about named entity recognition. So you can see the whole small paragraph. So Google is an organization, so it will uh, recognize this as organization. ORG is organization. Apple is an organization, so ORG. Then Siri is a product, so it will be uh, displayed as a product. So all these are named entity recognition. Okay, in a text, it will recognize the what exactly is that. If there is a person name, then it will recognize that as a person. Okay, and then we have, yeah, so that's named entity recognition. Then we have something known as n-grams, which is very important. So n-grams is combination of n words together in a particular text. Like for example, we have a simple text like this is a sample text. So n equals to 2 is bigrams, 3 is trigrams, and so on. So the bigrams are like this. It will divide the whole sentence into something like this. This is a sample text. So it will combine all the words into two words, okay, pairs of words. So this is a bigram. Similarly, we can have trigrams, we can have others. This is a simple example. So these are unigrams. So unigrams are only one words. This is a bigram, combination of two words. This is a trigram, combination of three words. Normally, bigrams are used in most of the cases because bigrams it is more powerful than unigrams and trigrams. So in trigrams, most of the information is lost. In unigrams, it's nearly the same case as trigrams, but for bigrams, we can get many things. So mostly bigrams are used. in many NLP tasks. So yeah, now bag of words. So what from the description only you can see like bag of words. So a bag where words are there. So it's a popular simple feature extraction technique which is used with text. Okay. So what it does is describes the occurrence of each word within a document. So document may be a sentence or a huge paragraph. So occurrence of each word, every word. Suppose okay, uh, any word it occurs three times, then that word will be three. Okay, occurrence of each word within a document. So for using this bag of words model, we have to design a vocabulary of known words. So tokens, and divide the whole thing into tokens, and then choose a measure of the presence of known words of the tokens. How to count, okay? And order or structure of words is discarded. I mean, if one word is coming before some kind of word, then that is not taken into care. It just counts the number of times that particular word is occurring within the whole document. Okay, so the model is just trying to understand if a word occurs in a document, but it doesn't know where the word is in the document. Okay, so this example, mm, okay, I'll just show the example. Yeah, I'll just show the whole example in the, yeah. So this is a simple implementation. So this particular line documents equals to this is what's known as initializing a list. This is how we initialize a blank list. So this represents a list documents which is now blank. Okay, this is how we initialize a blank list. Then we have a text. Yeah, this is a text. So it contains of many sentences. Now what we will do is we will first divide this into sentences, individual sentences. Okay. So this line, it divides everything into sentences. Then for each sentence in sentences, documents.append sentence. This means appending the sentences into the blank list. So I'll just run this. So you see, first the whole things will be divided into different sentences. I'll show you how you can get this. Okay. So these are the sentences. Then for this particular thing is the whole list of documents. Okay. Documents.append sentence. Each sentence will be appended. Appended means added in the blank list, right? So yeah, so this is how you append things into a list. Now this is a list of the sentences. Now what we will do is we'll take this list of sentences. Okay. Now we'll import the libraries that we need. Okay, from sklearn is a library. From sklearn, we will import count vectorizer, which is a module. Okay, from sklearn also, I mean, this is a whole library. sklearn.featureextraction.txt is a whole library. We'll import from this particular module and import pandas as PD. So pandas is also a library which is used for which is basically used for data uh, analysis kind of thing. So then we'll design the vocabulary. Okay. So what we will do is we will first remove everything from, we'll remove the words such as I and all these things. Okay. Stopwatch kind of thing. So this calls the whole function, count vectorizer function. Okay, count vectorizer. After that, we will create the bag of words module. So we already have something known as fit transform module inside count vectorizer. So we will just call this particular function and pass the whole list of sentences. So it will do everything on its own. You just have to call the whole, call the modules, particular modules. After that, we will get the feature names. This is also one module which is already there in count vectorizer. Okay, after that, we will use pandas data frame. Data frame is this whole thing. Okay, this is known as a data frame. So we'll use pandas data frame just for displaying the whole bag of words with the features. Features means how many times it occurs. Sorry. So you can see the whole sentences. Uh, okay. So we have the sentences. I like this movie. It's funny, and I hate this movie. This is awesome, and everything. Right. So these numbers represents the sentences. 0, 1, 2, 3, 4, 5. So these are the sentences. 0, 1, 2, 3, 4, 5. Okay. So we have 6 sentences. Then in the first sentence, how many times this particular word occurs? 0. Funny, it occurs once. It, like, these two occurs once. Okay. So these are the occurrence of the words in each sentence. Okay, so this whole thing is a data frame. So this is how you implement a bag of words structure. This is just for a few sentences. Now, if a document is very large, it consists of thousands of sentences, then the data frame will be very large, and you need more space for that. So this is bag of words. It just counts the occurrences of words in a whole document. Okay. So now for the whole document, you can say that this particular word is occurring 3 times, like 1, 2, 3. And this doesn't take into account the order. Now see, all the words are not in order. It's just there. It will just count how many times it occurs. So yeah, that's all about bag of words. Okay. Now we'll come to something known as TF-IDF. Okay, I'll just show you. I'll just show the slides. So yeah, that's how you can do a bag of words implementation. You can just play with the code if you're familiar with Python. If you're not familiar with Python, then just learn the basics of Python, and then you can try all the codes. You can try any other sentences with the codes. And then we have something known as TF-IDF, term frequency inverse document frequency. Now, what happens is using bag of words, we just get the counts of each word in the whole document. But that's not very useful in certain cases. If the document is very large, then what we need is something known as TF-IDF. So TF-IDF, it gives the importance of a particular term in a corpus. Suppose a word is very important in the whole corpus, then TF-IDF will give more importance to that particular word. How it does is it uses this kind of this formula. Okay, you don't need to go into details of this formula. You just need to know that if a particular term is occurring more, okay, it's occurring more in a range of documents, then that particular word will be given more importance. Okay, so that's term frequency inverse document frequency. So term frequency means that particular frequency of the term. Inverse document frequency is how many times it occurs in the whole documents. Okay, all the documents. That's TF-IDF. This is the whole formula. So number of occurrences of the word. Okay, this TF, number of occurrences of the word frequency. Then the number of documents containing the word, and this is the total number of documents. Okay, suppose 5 documents contains the words, and there are 10 documents. So this will figure out the whole inverse document frequency, and this is the term frequency. And then you will get the TF-IDF score for the word. How we do is, I'll just show you how we do. You can just try out. Okay, so I have just written the thing in more details here. You can just see why TF-IDF is important. So, okay. So yeah, you can see this last line. It increases proportionally to the number of words, number of times a word appears in the document. It is offset by the number of documents. Okay, how many documents contains that word? Okay, now this simple few lines will give us the TF-IDF score of all the words in the same sentences. So I'm taking the same sentences. There, you just have to call the module, and it will take care of the rest. It's similar to how count vectorizer is used, but instead of count vectorizer, we are using TF-IDF vectorizer. Okay, so you just pass the documents, and you will get the whole TF-IDF scores of all the words. So this is how we get the TF-IDF scores. It's important when you do certain tasks in NLP, getting the TF-IDF score. So yeah, that's the thing. You can try the whole notebook, and I have just two more slides. This is just the last slide for today. So recent trends in the field of NLP. So we have detection of misinformation in social media, such as Twitter and Facebook, fake news detection. Then opinion mining for products, restaurants, hotel reviews. Opinion mining, I mean, it's sentiment analysis, basically. If opinions are negative, neutral, or positive, you can see these things in Amazon or Flipkart reviews. You can check if something is positive or negative. And real-time speech to text, these things, Siri, Alexa, all these things. Then evolution of natural language understanding. So this is a different thing. Understanding all natural languages, building language models and stuff like that falls under this natural language understanding. So it's a bit advanced kind of thing. So yeah, those are the recent trends in the field of NLP. So today's today's session. Tomorrow we'll just go a bit more into details of some other things that I'll show you. So I hope the basics are clear with everyone. If you have any doubts, you can ask. Okay. So yeah, I'll just stop the screen sharing. Hmm. You can just go through the slides. I'll share the slides with Akansha. You can distribute to everyone. Yeah.
Okay, sir.
Yeah. Yeah. Sure. Yeah. Yeah. You can ask him. Yeah.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.